today we're going to be recording the AS Chemistry Week 4 quiz, and I'm only going to be solving the first 8 questions because the rest are the copy-paste of last week's video. So refer to last week's video for the rest of the questions, please. And I'm only going to be doing the new ones here. Now, which of the following are not produced by this reaction, which is magnesium oxide reacting with nitric acid? Now, magnesium oxide is MgO plus nitric acid, which is HNO3. Which of the following will not be produced? Now, we know that Mg and NO3 will combine. So we're gonna get Mg NO3, and there you need to add 2. What's gonna be left? We have O and H. Whenever you see O and H, you know it's gonna form H2O, which is water. Just memorize. So it's not gonna form NO2 nor MgOH. It's gonna form this and this. So we can select the ones that it is not going to choose. Now, write the equation of the thermal decomposition. Now now we have Mg NO3 2, because Mg is Mg2 plus and NO3 is NO3 minus. When it thermally decomposes, it just splits up. Now, whenever you have a nitrate or carbonate splitting up, it's always gonna form an oxide. So you're always gonna have MgO plus NO2 plus O2, and you definitely have to balance it out, because now we need since we have 3 O's, we have 6 O here. We're gonna need 2 MgO, 2 of this. So 2 of this means 2 times N, which makes it 2, and times 2 makes it 4. So 4 NO2. Yeah. So now that's it. That's balanced. Now the thermal stability, as you go down in the nitrates for group 2, it increases. This you need to memorize. So thermal stabilities of group 2 nitrates increases when you go down. Moving on. Oxidation numbers, we should all know this from last year. K is group 1, so it's gonna have +1. O is -2. Now O is -2, we're gonna multiply it by the 3, -6. N we don't know, so I will put it as X. And then here you have +1. +1 minus 6 is -5, so it's X minus 5 equals 0. X equals 5. So N is 5 plus 5 here. Now KNO2. KNO2. We know K is 1 and O is -2. So this is 1. O -2 times the subscript, which is 2, -4 plus X. So now 1 -4 is gonna be -3. X equals 3. So, and O2, since it is just like O, it's like an atom, it's 0. So nitrogen, what happened to it? This was the reactants and this is the products. Nitrogen went from being +5 to -3, so it got reduced. Oxygen went from being -2 to 0, so it got oxidized because it got bigger. Moving on to question 2. Now question 2 is telling us when heated, 0.40 moles of group 2 carbonate decomposes to produce 60 centimeter cubed of carbon dioxide gas. How many moles of the same group 2 nitrate must decompose to produce 60 centimeters of gas? Now, to do this, let us first write down like a formula. So a metal carbonate, when it decomposes, it forms metal oxide plus carbon dioxide gas in a ratio of 1 to 1 for the gases. Now, when we have metal nitrate, decomposes into MO plus NO2, but when you balance it, you need 2 MO and you need like 2 NO2, I think. Yeah, 2 NO2 because you have 2 nitrogens. We don't need 2 MO, by the way, that was a mistake. And you need 2 O2 if I'm not balancing wrong. So you have 1 M, then you have 4 plus 4, 8. No, wait, it's half oxygen. Because we want to try to keep M here, we need to try to keep it 1. So it's half oxygen when you balance it. So now we have, how many moles of oxygen are you producing? It's 2.5. So it's 2.5. Here you're producing 1 mole. So if you're producing 1 mole, so it's 1 times 0.4 moles. You're taking it like it's a ratio, equals it's gonna be equal to 2.5 times how many moles? Once you solve it, you're gonna get 0.16 moles. You're finding the ratio between them. So if you have 1 mole, which is 0.4, and here you have 2.4 moles of gas, how much do you need to form the same same volume of gas? Moving on. Here, this you really need to focus, because you also need to notice a few things. Now, the only group 2 metal that does not have a color is magnesium. So you take the hint that this is magnesium. And the only flame that's brick red is calcium. Now, when you see brown gas released, no, it is nitrogen dioxide. Here, colorless gas, it can only be carbon dioxide, especially because it's insoluble and has effervescence with gas. So now, here it's just telling you it's soluble. So we already know everything we need to know. X is NO2, the gas released, and CO2 is from Y. So since this is the case, and we already found out that it's MgNO3 and CaCO3 from the flame tests. Now for the next parts, it's just random questions asking you to write chemical equations. I find these very annoying, by the way. So the thermal decomposition of magnesium carbonate. You write down first magnesium carbonate. Then we said whenever you thermally decompose, you're going to form an oxide. So it's MgO. Now what's left? You took 1 O, so it became CO2. That's what's left. So CO2 is what is left. Now here it's between magnesium and water. So now you just write magnesium and water down. MgOH is going to react. And then you're going to be left with H2. And you just need to balance. I can't really help you with chemical equations because we've been doing them for so long. You just need to really understand that it's you're taking the positive with the negative from the second reactant and vice versa, you know? We should know how to solve chemical reactions by now. This question is almost the exact same as the one before it, just with different compounds. Scarlet color means it's strontium. No change in color means it's magnesium again. Brown gas, NO2. Colorless, CO2. First question, exact same. Second question, it's SrNO3O2 and MgCO3. And again, they want you to do the exact same thing in the last question. And they're even the exact same products, exact same everything. Just Ca is the different than magnesium. Now moving on to our next question. Okay, so you have a gas Ca. What happens to the gas Ca when you add it to dilute HCl? It's gonna form CaCl plus H2 gas. What happens when you roast it in air? Roasting it in air means adding كأنه reacting it with oxygen. Whenever you roast it, it's gonna give you a oxide. So CaO, and with H2O, we said calcium is gonna react with the OH, forming CaOH2. And that's the first part answered. CaCl2, by the way. Now, why? Oh yeah. So compound U, aka CaCl2, reacts with sodium carbonate NaCO3 to give a compound Y. So it's gonna most likely be NaCl plus CaCO3 Now, choose the state of Y. They're never going to be talking about this. They're always going to be talking about this one, okay? So compound Y is CaCO3. Carbonates are never soluble except with the few exceptions we took last year. You need to remember solubility rules. CaCO3 is not soluble, so it is a solid. And last week in the MS, there was a question that came. It was, what's it called? Calcium sulfate. We had to write it down in a reaction. Most people put down calcium sulfate as aqueous. Calcium sulfate is not soluble at all. Calcium sulfate is a solid. So you cannot write down aqueous. And a lot of students got that wrong from last week's AMS quiz. AMS and AS. Chem. So yeah, we said the formula of Y is CaCO3. Moving on. Give the formula of gas that Y would release upon thermal decomposition. Since it has a carbonate, it's always gonna release CO2. Now compound V, let's go back to see what's compound V. CaO. Now CaO can react with nitric acid, HNO3, to give compound W. Again, you're most likely gonna need two of this. No. Honestly, don't balance. Just don't balance. Because it's gonna form H2O plus CaNO3. And NO3 is 2 because Ca is a charge of plus 2. And that's W. And then when you're gonna thermally decompose it, as you can see, there's already an NO3, so you're gonna get nitrogen gas. Or nitrogen dioxide, my bad. Now compound X, which is CaOH, 2, reacts with dilute sulfuric acid, forming CaSO4, and here it is again. Now whenever you have base with acid, it's neutralization. CaSO4 is a solid because it is not soluble. Remember it well, because last time she brought it, it tricked a lot of questions. A lot of students complained that the question was wrong, and they couldn't take it as a bonus because in fact the question was not wrong. Moving on. It's this, no, new question. Now, complete the electronic configurations of each. CaO, we know how to complete the electronic configurations because they already gave us up till here, I think. Ca is 20, Sr is 38, if I'm not mistaken. Yes. So here, just continue on. This makes 10. So then you have 3s2 is 12, 3p6, 18, 4s2, 20. I think we all know how to write electronic configurations by now. You use the backwards method from SPDF. Now, 38, you do the same thing, but you go on till 38. But you're going to say this isn't 38 because we have an ion. So what we're missing here is 5s2. Whenever we need to add the ion charge, you look, what's the biggest energy level? Here it is 5. And here the biggest is 5s. There's no 5p, nor 5d. If there's 5p or d, you take from them. But since 5 here is the biggest and it's s, we take from it 2, leaving it with nothing. So it disappears. The atomic radius of calcium is smaller than the atomic radius of Sr because calcium has less protons, so it's gonna have a less atomic radius. And it has less electrons. So since it has less electrons and protons, it is definitely gonna have less atomic radius. First ionization energy of calcium is greater than because when you go down a group, it decreases. When you go down a group, it decreases. When you go across, it increases. If you did the AP quiz, you would know. Size of a strontium atom is bigger than the size of a strontium ion. Why? Because the size of a strontium ion, an ion is neutral, but the atom is neutral, but the ion is Sr2+. So you're gonna say, what does that have anything to do? 2+ means it lost 2 electrons. So if it loses 2 electrons, means it has 2 more protons. So since we have a higher positive charge than the negative charge, you're gonna have more positive charges pulling in whatever electrons we already have. So the electrons are gonna be pulled in closer to the nucleus, making the atom shrink in size, because you have way more positive energy pulling everything towards it. So the atom is gonna be bigger than the positive cation, whereas in anions, the anion is bigger than the atom. Now calcium reacts less vigorous because when we go down a group, reactivity increases. Now the solution obtained with calcium with water has a lower pH because strontium is under calcium and reactivity increases, so it's gonna react stronger with water, so it is gonna give a higher pH. Strontium, not calcium. Moving on. Here they just want you to decompose strontium nitrate. Whenever you have nitrate, know that your products are gonna be the same. Your products are gonna be the metal oxide, NO2 gas, and O2 gas. Most likely this is gonna have 2 and this is gonna have 4. But you can balance it there on the spot. And I don't know why here they're very annoying with this box thing. I think they even marked the question wrong because of the boxes. Anyways, the color of the red, scarlet red, because of strontium being scarlet red. Now here, to solve this question, there's a very easy way. So we have that 5 grams of strontium was used, and the molar mass is 211.6. First of all, I want you to find the moles of strontium nitrate. Is it nitrate? Yeah. Nitrite. Doesn't matter. Yeah, nitrate. Strontium nitrate. So we're gonna do 5 divided by molar mass, 211.6, which is gonna give us, let me check really quick. So okay, so I checked, it is 0.02363. Anyways, so that's the mole ratio. Now we need to find how many moles of gases is formed, how many gaseous moles is formed. So first of all, here we have CO2 is a gas, it has 2 moles. N2 is a gas, it has 1 mole. CO2 is a gas, CO is a gas, it has 1 mole. Add them, you have 4 gaseous moles. Since we have 4 gaseous moles, you can multiply the moles of gases times how many moles you have. So this times 4. It's gonna give us 0.0945. And so now since we have that number, we could take this number, and this number is how many moles you have. You multiply it by RTP, which is times 48, and you get 24, and you get 2.27. And that is it for this question. Moving on to our last 2 questions. They're the same concept, the last 2 questions, by the way. Exact same concept. So now, write the chemical form. Whenever you see brown gas in tomorrow, no, it's not an O2. Now, so the group metal produces a pale green color flame. Please open CQDs, open your notes, open the book, find the colors of the group 2 metals. Please read the book, because this year we don't have notes. We could study best, so we really need to study the book this year. I even studied the book. So now we have pale green color, so it's barium. and it's gonna form a nitrate since it's a nitrogen dioxide gas is being released. Here we need to decompose it. I think if by now you should already have the composition memorized. 2 moles of oxide, 4 moles of NO2, and 1 mole of O2 gas. Memorize it at this point. And 2 moles of the this part. I forgot, it's the solid, the nitrate. Now moving on, they just want you to do the one with water. BAO, they want Z. Z is, we already said Z is, wait, where do we have Z? My bad, guys. Oh yeah, compound X plus heat. When you react it, you have Z. Oh yeah, this is Z. So then you have BAO plus H2O. Again, oxide with water. It's like it is it's just you combine everything. So BAO, H2. It's perfectly combinable. Now write it for Y with HCl. Y would be this. With HCl is gonna be BaCl2 plus 2H2O because it is a neutralization reaction of an acid with a base. Now moving on to the next question, which is the exact same thing except with carbonates. Here, colorless gas, so it's as carbonate or carbon dioxide, my bad. And here we have brick red, which means it's calcium carbonate. And decomposition, same thing, CaO plus CO2 for the carbonates. And then you need CaCO3. They want you to react it with compound X, yeah. They want you to react it with H2SO4. It's gonna be calcium sulfate, which is a solid. Please memorize it's a solid. And H2O liquid and CO2 gas. Memorize these formulas. I'm not telling you memorize, like for Ca memorize it because it is solid. Most aren't, but this one's solid. So yeah, the solubility of sulfates decreases down the group. So strontium is soluble, but when you go down it's not soluble anymore. Hydroxide increases down the group. So strontium wouldn't be soluble with hydroxides, but it would be with calcium is not soluble. No. I was right the first time. Strontium is not soluble or not that soluble with hydroxides, but calcium would be more. Anyways, that's it for the new questions of this quiz. Hope you understood everything. Have a great day. Bye.